Hi guys. So I'm going to take a moment to introduce a new conversion on our stoichiometry map. So what we're trying to do is we're trying to develop this kind of map where we go, we find ways to convert from moles of known to moles of unknown, and we can come from mass, we can come from number of particles. We can use the molar ratio to convert from moles of known to moles of unknown, and then we can leave the problem in mass or particles. So what I want to do is I want to add to this map today, and what we're going to do is we're going to use this concept of volume of gas. Okay, there's a direct relationship between volume in gas and moles of gas if that gas is at 1 atmosphere of pressure and 0 degrees Celsius. Okay, these conditions are called standard temperature and pressure, or they're abbreviated STP. Okay, so at standard temperature and pressure, we have this relationship. 1 mole of gas at STP, that is at 1 atmosphere and 1 at 0 degrees Celsius, is 22.4 liters of gas. Okay, so we can use this conversion factor if we have volume in liters, we can divide by 22.4 and get moles of gas. And similarly, if we have moles of unknown and it happens to be a gas and it happens to be at standard temperature and pressure, we can convert to volume of gas by multiplying by 22.4 liters per mole. Okay, so let me show you what this looks like. We have a problem here that says what volume of oxygen is produced at STP when 6.58 times 10 to the 24th molecules of water, it should be R, decompose according to the following reaction. This is a balanced reaction. Okay, so in this case, we're going to start, here's our given. We're going to start with molecules of water. And here's what we're trying to find, volume of oxygen. In this case, we're going to find the volume in liters. Okay, so we will start here with our given. All right, we're going to say 6.58 times 10 to the 24th molecules of water. And we want to get to moles of known. In this case, we're going to divide by 6.02 times 10 to the 23rd molecules of water. Water in one mole of water. Okay, now we're in moles of known. We're going to go back to our molar ratio, and we're going to use the fact that 2 moles of water give us 1 mole of oxygen. Okay, in this case, we're not interested in the mass of the oxygen gas. We're interested in its volume. So we can use our new conversion factor. This is gas at STP is 22.4 liters per mole. All right, so 1 mole of oxygen is 22.4 liters of oxygen. Okay, let's check my units, see if they drop out. Moles of oxygen drop out, moles of water drop out, molecules of water drop out, molecules of water drop out. Okay, I'm going back to my calculator. And actually, go ahead and pause this for a minute right now and work through the math. If you do so, 6.58 10 to the 24th times 22.4 divided by 6.02 times 10 to the 23rd divided by 2. I get 122.4 liters of oxygen gas. Okay, please take a moment. Actually, I'll do one more of these for you. I think I have another one on this. All right, so here's another problem, similar. All right, and in this case, so ideally what you would do is take a moment and try this problem on your own. Hit the pause button on the video. All right, please take a moment to do that, and then I will work through this. Welcome back, because I know that you paused that button, and I know that you worked through this on your own. I just have that feeling. So in this case, I'm asked how many liters of nitrogen gas are needed to react with 90 grams of potassium at STP. This is clear. Careful. You might say, well, what if I'm not at STP? Well, then you cannot use that conversion factor. You cannot say you have 22.4 liters of gas per mole. All right? In that case, if you're not at STP, you can't do the problem, at least not until we do our unit on gases. Okay? So, given 90 grams of potassium, how many liters of nitrogen gas are you going to make? All right, so we start here. We have 90 grams of potassium. We're going to need, we're in mass, we need to get to moles of known. All right, 1 mole of potassium has a mass of 39.1 grams. Okay, then we're going to go to our, this does happen to be a balanced formula, and we're interested in the relationship between potassium and nitrogen gas. Okay, so 6 moles, to completely react 6 moles of potassium, it requires 1 mole of nitrogen gas. Okay, we are told it's at STP, so we are allowed to say that 1 mole of nitrogen gas is 22.4 liters of nitrogen gas. Okay, liters of nitrogen gas is the unit I'm interested in. My moles of nitrogen cross out. My moles of nitrogen cross out. Moles of potassium, grams of potassium, grams of potassium. Okay, so if we go to our friendly handy-dandy iPhone calculator, we take 90 times 22.4 divided by 39.1 divided by 6 equals 8.59. Now the unit is liters of nitrogen gas. Okay, that's our answer. Does this make sense to us? 90 over 39 is a little bit more than 2. 2 divided by 6 is about 0.6. A little less than half of 20 is 8.6. So that does make sense to me. Okay, I hope this helps. And we'll see you soon.